Assalamualaikum and very good morning to everyone. Welcome to Group 2, Assignment 2. This assignment will be presented by three students, which is me, myself, Muhammad Arif bin Idris. And then we have K.Thanesharan, lelaki S.Kanan, and Chee Shawn. So the presentation will be on the overall equipment effectiveness, OEE, and I would like to thank our lecturer, IRTS Dr. Hasrul Akhmal, for the knowledge that he shared during the emerging class. Okay. So first of all, let's go with the agenda. So today we're going to discuss on the objective, introduction, background, path of mastering the OEE factor, 6 losses, the toolkit, calculation, benefits and difficulties, case study, and last but not least, conclusion and the references. Okay, on the introduction, so OEE basically is the gold standard for measuring manufacturing productivity. We can simply explain it determines the proportion of manufacturing time that is actually productive. And then the OEE score of 100% means you are manufacturing only good parts as rapidly as feasible with no stop time. So in OEE terminology, this signifies 100%, 100% again, quality, performance, and availability, which we're going to discuss further on that one on the next slide. And then measuring OEE is the best practice in manufacturing. We were required to crucial insight in how to systematically improve our manufacturing process by evaluating OEE and the underlying losses. And then last but not least, OEE is the single most effective statistic for identifying losses, evaluating progress, and improving manufacturing equipment productivity. So this one of it is eliminating the waste. On the background development timeline, so we can see the OEE history. So which is this one basically start early 90s. So before 1950, so a lot of breakdown maintenance. So it's keep improving from 1915 to uh, 1971. From the preventive maintenance, we do the maintenance, we do the corrective and the productive maintenance. So on 1971, they introduced the TPM, which is this one I believe had been presented by Group 1 on the TPM. And then by 1988, the OEE had been introduced by Nakajima. Okay. So path, next slide is on the path of mastering the OEE. So the keywords on the path of mastering the OEE, basically the availability, performance, quality, and all of this, when we combine, we get the overall equipment effectiveness, OEE. Okay. So briefly about the availability is unplanned, unplanned stop. And the performance is a slow cycle and small stop. Quality is a defect which is considered in quality, which is including parts that need rework. Okay. We go for the factor of the OEE. So basically OEE tells, score tells you where you are at, but the three underlying factor that we previously discussed, availability, performance, quality, tell you where you should focus your improvement efforts. So we can see this, we have the all time, planned productive production time, runtime, net runtime, and fully productive time. We consider on the schedule losses, availability losses, performance losses, and quality losses. So we go for the first factor, which is all time. So all time is basically when you subtract the schedule losses, which includes all time that should be excluded from OEE analysis because there is no intention of running production during this time, which is planned shutdowns, breaks, lunches, or periods where there are no orders. And we can say schedule loss is part of TEEP, total effective equipment performance. we can say that one basically is not part of OEE. Okay, when we understand that one, so the remaining time from the old time is our planned production time. So OEE begins with planned production time, scrutinize all efficiency and productivity losses that occur within that time with the goal of reducing or eliminating these losses. Okay, from the runtime, basically, this is what we discussed earlier on the availability. Availability takes into account availability loss, which include any events that stop planned production for an appreciable length of time, usually several times, long enough for an operator to log on the reason. Examples of things that create availability losses include unplanned stop, such as equipment failures, material shortage, and planned stop, such as changeover time. So this one, availability loss, is very close to the machineries. So, and then we go to the third point, which is the changeover time is included in the OEE analysis, since it is time that could otherwise be used for manufacturing. While it may not be possible to eliminate changeover time, in most cases it can significantly reduce. So the remaining time after availability losses is called is runtime. Okay. And then we go for the net runtime. The performance take into account performance loss, which account for anything that causes the manufacturing process to run at less than the maximum possible speed when it's running. So this one including both slow cycles and small stops. Small stop example of things that create performance loss, including machine wear, substandard materials, misfits, and jams. The remaining time after formula loss is subtracted is called net run time. Okay, and then we go to the third point, which is the fully productive time, which is the remaining time after the quality loss is called the fully productive time. So this one is quality times takes into account quality loss, which account for manufacturers parts that do not meet quality standard. So this one is an example of things that create quality loss, include scrap and parts that need rework. OEE quality is similar to first year pass year. In that, it defines a good part as parts that successfully pass through the manufacturing process the first time without needing any rework. Okay, I think that's all from my side. So I think Tanesh will continue on the next slide from his part. Okay, thank you very much.
Hi all, I'm Tanesh. I'll be presenting on the 6 big losses and also the calculation of OEE. The 6 big losses is the concept and practice of categorizing productivity loss from an equipment perspective. It aligns directly with OEE and provide an additional and actionable level of detail about OEE losses. We already know OEE provides useful information for decisions making at different times. OEE also measures the percentage of plant production time that is truly productive. Many manufacturing lines are only 60% productive, meaning there are tremendous opportunities for improvement. So why use 6 big losses? It allows us to accurately pinpoint the area of workers that will impact on the performance of the equipment's output. Improvement tool will be used to reduce each loss. The 6 loss will break down the equipment's overall loss into 6 clear categories, which we can apply certain techniques to improve. Integrating 6 loss data with using the right tools on the acceleration speed of execution will improve the performance of your equipment. As per research, many manufacturing plants spend time in measuring and recording data but don't use most of it. So there are 6 big losses. The first is the planned downtime. Second is the breakdown. Third is the minus stop. Fourth is speed loss. Fifth is the quality loss on startup. And sixth is the quality loss in process. So what is planned downtime? Planned stops, planned downtime are periods of time in which the equipment is scheduled for production but is not running due to a planned event. Examples including changeovers, tooling adjustments, cleaning, flavor changes, hygiene, quality inspections, and cooling will be the breakdown.
Breakdown are a significant period of time in which equipment is scheduled for production but is not running due to an unplanned event. For example, equipment breakdown, tool failure, unplanned maintenance, lack of operators, materials issues, that kind of issues. Third will be the minor stops. Minor stops occur when equipment stops for a short period of time, uh, which is lesser than 5 minutes usually. The stop is resolved by the operator. Minor stops are often chronic, which can make operators somewhat blind to their impact. Examples of minor stops include misfits, material jams, incorrect settings, misaligned. Following with the speed loss. Speed loss occur when the equipment runs slower than the ideal cycle time, which is the theoretical time. So, for example, it would be the worn-out equipment, poor lubrication, poor environmental conditions. Okay, the following will be the quality loss and process. Loss and process are defective parts produced during stable production. This includes parts that can be reworked, uh, since the OEE measures quality from a first pass in perspective. For example, it includes incorrect equipment settings, mistakes from the operators, equipment handling errors, that kind of things. And sixth will be the quality loss on startup. Quality loss on startup are defective parts produced from startup until stable production is reached. They can occur after any equipment startup. However, that are most commonly tracked after changeovers. Examples are suboptimal changeovers, equipment that needs warm-up cycles, and equipment that inherently creates waste after startup. Okay, the 6 loss toolkit. As you already know, the OEE measures into three. First is the availability, second is the performance, and third is the quality. And for each category is already divided into two. So for availability, it's the planned downtime and breakdowns. So for the planned downtimes, the reason for loss are the changeovers, plant maintenance, material shortages, and labor shortages. And for the countermeasures, the planned downtime management, 5S workable organization, ABC planning. For breakdowns, the reasons of loss is equipment's failure, major component failure, unplanned maintenance, and for the countermeasure is the root cause analysis and asset care. For minor stops, the reason for loss is the fallen product, obstruction, blockages, and misalignments, and the countermeasures are cleaning, 5S workplace, 5S workplace organization, and adjustments. For the speed loss, the reason for loss are the running lower than the rated speed, or the ideal speed, untrained operator not able to run at the nominal speed. So the countermeasures are line balance optimization and adjustments. For the production rejects, the reason for loss is the loss of the product out of specification, damaged product, and scrap. And for the countermeasures are the Six Sigma, error proofing, and root cause analysis. And the last one will be the reject on startup. The reason for loss is the product out of specification at start of run, scrap created before nominal running after changeover, damaged product after planned maintenance activity, and the countermeasures are the planned downtime management, FIFO's workplace organization, and precision settings. So calculating the 6 losses. So for the total production time, it's always the total time minus the NRFP. And for the planned downtime, it's the planned downtime with the total production time. Okay, the breakdowns and minor stops are having a same calculation, but the only difference is the time taken for it to recover. So breakdowns are normally more than 5 minutes, and minor stops are normally less than 5 minutes. So for both of them, the formula will be time loss at critical machine due to stoppages over total production time. For speed loss, it's the good output of actual speed minus good output of related speed divided by total production time. Production rejects are the rejects in production over actual speed times total production. And for rejects on startup, rejects on startup over actual speed times total production. Okay, so the benefits of 6 peak losses. So the 6 peak losses always keeps the focus on the biggest area of opportunity tactically and strategically. It allows leaders to formulate medium to long-term strategic plan. It also provides feedbacks and keep tracks of progress. To make it a simpler terms, in the short term, 6 big losses provides additional information that aligns with an external OEE. And also in the long term, 6 big losses make it easier to identify effective countermeasures for equipment-based losses. Key insights for 6 big losses. The first one, monitor the constraint. Every manufacturing process has a constraint, which is the fulcrum for the entire process. Measure 6 big losses at the constraint and focus your improvement efforts to improve the constraint. This will be the fastest path to improve throughput and profitability. The second, don't hide loss. Time that can be used for value-added production should be used for value-added production. If it's not, the time should be categorized as a loss. These tricks then derive innovation and improvement. Every loss can be targeted and improved. Third one, standardize changeover time measurement. Measure changeover time accurately and consistently by standardizing the measurement. It's usually measured as the time between the last good part of the prior to the run to the first good part of the next run. You can define as our own standard. The important thing is to be the consistent. The fourth one will be the create a 6 big loss rule book. Consistency is important when using the 6 big losses as a benchmark or as a baseline. Create written standards to ensure consistency. I'll be showing the 6 big loss rule book example on the next slide. So moving on to the next point, automate data capture. Automated data capture significantly improves measures accuracy for unplanned and planned stops, and is the only way to accurately measure and differentiate losses from slow cycles and small stops. The last one, actions speak louder than words. The 6 big losses provide valuable information and insights, but most of the value comes from using the information to drive actions. An excellent framework for driving action is the combination of IDA and structured improvement. 6 big loss rule book. So this is our example of a 6 big loss rule book. So as we can see, they have already categorized everything into 6 big losses, and by doing this, we can avoid any losses in current, now, or in the future also. So I think that's it from me. So I'll proceed to Shawn to present regarding these case studies. Thank you.
Hi everyone. Yeah, it's my turn. After we discuss about the 6 big losses, now we are coming to the case study. So the case study we're having here is actually the New Belgium Brewing Company. So it's based in Colorado and started as a small batch hobby brewery. So, but it quickly became the nation's third biggest craft brewery because of the famous. So the demand is going up. When the demand is going up, so the current system, current production flow, unable to match the production needed. So quickly, their brewing operation quickly reach capacity, and then their bottling unable to keep up. So they're struggling to identify what is going on in between in terms of the efficiencies and inefficiencies in their bottling line. Why they couldn't provide the maximum output. So over here, when they started for these improvement investigations and implementations, so the goal is actually to increase the production capacity and then enhance the overall equipment effectiveness, including the high quality output, the effective management, availability of the production line during the plant out stage, and then the package change, and then the maintenance operations. So the goal also in order to increase the case production by twofold and run at full capacity. The challenge that they are facing, so when they come, in order to achieving the so-called high OEE, they face some difficulty. First thing, the data. So as you know, based on the manual recording data, no data of real-time information during the unscheduled downtime on various equipment and causing slowdown is actually recorded. And then the downtime also split out their manpower production team, and then they need to constantly react to the unscheduled downtime on the certain assets rather than the man hour is actually putting into maximize the output. And then for the production, although they can produce those capacity, but the bottling operations didn't have the ability to predict the forecast, so some higher, sometimes lower because of the efficiency. So even though they have the demand, even though they have the orders, but they are unable to commit the estimated production quantity to the client. So come to the implementation part. So the first thing, they need to make the production line to be stable. So they implemented the manufacturing automation software as well as the system in order to ensure that everything is the cycle time is stable and can be estimated. So based on this stable cycle time, they can come up with what is the maximum potential for the system. So here is the figure. The maximum capacity is 294,000 cases per week. But when it comes to the actual productions, only reach 150,000. So after audit, this due to the schedule and schedule downtime, which cut off the actual production from the maximum potential output. And also, they also upgraded their automation system from the manual data recording to the software and the system, which can record a massive amount of data can be collected and put into the context. And they also use a software-based system to manage the data, which I mentioned just now, the massive data collected, in order to transform into the planning and then the schedule and so forth. So this great visibility of the overall productions picture led to the real understanding of the actual production capacity, which they come up with the stable production line, come up with the maximum output, and then what is going on in between to prevent them from keeping up with the maximum output. And then from over there, they need data. So they collect the data. And after collect the data, they need to analyze the data and transform the data into the useful information which can be put into their production schedule of production plans. So in this case, this is why over here they're saying that about the great visibility of the overall productions. So in the final outcome, this is the final outcome for after implementations, the OEE from 45% to 65% over 2 years. And then the downtime reduced by 50+%. And then the runtime efficiency is going up at least 25 to 30%. And the production can reach weekly 190,000 to 200,000 consistently. Just now we mentioned that it only reached 150,000. Now increase at least nearly 30%. And then the packaging area capacity can be reached 1.3 million a year. So can match their demand and the production output. And then overall, this also reduced the operation costs and also dealing the capital investment. So over here, we can see that the benefits, the first one is actually mainly will be return of investment for the equipment. Okay. This because normally the companies is actually investing heavily in the machinery. So it's quite important to maximize the return on this investment because it's upfront. So if you can use the OEE strategy to produce like 15% more products on the same equipment at the same amount of time, so it can greatly impact your bottom line. Also, it will increase the competitiveness. So manufacturer always trying to strive for reduce the losses during production to achieve maximum competitiveness. Using the data from the OEE, so you can identify where's the bottleneck and the weakness in the productions, which allow you to take the immediate actions. So OEE not just the number, it's through process you understood that where is the point with slowing down the productions. So the third one is cutting the machinery costs. So they can help you to understand the equipment actual performance. So you know that how efficiently the equipment is working. So it's also alert you to issue that may lead to the future breakdowns and repairs in advance. That's quite important. And overall equipment effectiveness help you to anticipate the potential machine failure, reducing maintenance costs and the downtime. And the fourth one will be the maximizer workforce productivity. So if you experience the operator downtime, and rebuild the productivity data and pinpoint long changeover or setup time information like this, it's actually help you to allocate better for the resources. So identify where is the excess capacity is occurring and where is the short of resources you need to make it up. So, and then also it will be reduce a lot of the manpower, which actually contribute to the downtime, used for the repair, used for the maintenance, used for the standby. So we should maximize our workforce for the productions. So, and the fifth one will be easily visualize the performance. So overall equipment effectiveness emphasize on visibility. So it's letting you to visualize the production problems instead of having to rely on your best guess by highlighting the biggest sources of the production losses into one single percentage. So everyone can see that what is working and where improvement is needed and where's the status at the moment. So, but apart of that, sometimes when doing the implementation of the OEE also have their own limitations. So there are times that actually the OEE can be not the most ideal KPI in order to evaluate the operation of the productions. So distinct difference exists between the manufacturer of large and small product mixes based on their target number for the individual aspect of OEE, availability, efficiency, and quality. So we take a look at the large mix. The large mix manufacturer, also known as the high mix or low volume. So produce a wide variety of products, complete with customization options. So manufacturing in machine building industry. So for instance, put a premium on flexibility over speed and efficiency. So at 100% OEE or even at a still excellent 85%, you lose the flexibility. So as a result, the target OEE varies widely based on the situations. So when we come to the small mix, so by contrast, a small mix manufacturer also known as the low mix high volume. So produce mass quantity of the same parts and products at a low cost and with a low defect rate. So customer product like the light bulbs and rolls of paper fall into this category. They strive to have a high quality and availability, but lower efficiency. In their case, a dip in efficiency actually foster the flexibility to increase the production as needed. As a result, a company in this group more likely to target on a high OEE. So that's the contrast between the large and the small mix. So where the OEE may have their limitation, or whether the OEE will be very suitable to as a KPI or as an assessment for the production line. So when we come about the OEE, so we always have the percentage. So we know that OEE is a benchmark to compare the performance of the provided assets, machinery, to in the organization assets. So because after you invest high cost for the machinery, you need to know how efficient they are working in order for your productions and in order for the turnover. So the outcome, as we know, that will be in terms of percentage. So how good is good, or what is the percentage which we should take note? So we can see that 40% is a low rating. So this where we should take initiative to reduce the downtime. 60% is a fair rating over here, but need to keep up for the improvement. Over here, we have 77%, but this figure maybe will change year to year. It's actually so-called ideally, they recommend that the minimum OEE rating reach in terms of recommendation. But if you reach 80 to 85%, it's considered a world-class rating. So it's not easy to maintain that. And it's actually required in those production like automobile, furniture, toys, and smartphones. So they aim for at least 85% in order to achieve their commercial target, on to meet the demand, and also in order to reduce the cost in the long run. So 100%, of course, this one is a perfect scale, and the facility is only producing the quality good as fast as possible without any downtime. So without any downtime, this is the 100%. So we can see that this is roughly the OEE benchmark over here. So now we come to the conclusion. So it's actually OEE is actually an indicator. So it's actually evaluate the effectiveness. It's a crucial indicator used by the enterprise to gauge the efficacy and efficiency of their manufacturing process. So with this one, they knew where they are, where are they going to heading to in order to increase the productions. If they have the low OEE and they keep on increase the production, so it means that they're running their production without good efficiency, so they need to put in a lot of investment, but the production is still low. Maybe will be even create more downtime for that. So, and then the performance. So this is OEE also the indicator to pinpoint the underperforming assets and link subpar performance to the problem with availability, performance, or quality. It's also a look ahead. So it's actually very useful for the purpose of organizing, scheduling, and carry out maintenance tasks. It's actually an important information to offer the helpful insight. So when we come to the when we receive the estimated demands or receive the massive orders, or even for the future market development, so we need to know that quite sure that whether we're able to meet target. So this is can provide a very good look ahead with the very good information, and also optimizations. So over time, it's actually help for the reduce the downtime. So it's a cost of the optimizations and also to maintenance strategy optimization. So in short, this OEE is very important because it's actually related to our target. So after the target, what is the actual? Whether we can reach our target. So apart from that, even though we can reach the actual number or estimated, what is the efficiency? So if we have the efficiency, high efficiency, so it means that we can run in lesser resources, but still maintain the similar production output. So, and lastly, the downtime. We need to maximize the hours, the machine operations every second to maximize the time is actually used for production rather than standby, repair, maintenance, or downtime and just for waiting. So this will be a waste for the production because the time is very crucial for them. So I think that's all at the moment. So these some of the references for our groups, and thank you for your attention. And if anything, feel free to drop the comments below, and including any questions. So will be answered shortly, and we'll try our best to answer as soon as possible. Yeah, thanks. Thank you. So I think that's all. Yeah, have a nice day.